Hello everyone, this is Mandeep Singh Shekhawat and today we will be discussing chapter 7 of designing data intensive application which is transactions. Transaction के बारे में हम आज डिटेल में डिस्कशन करने वाले हैं. What do you mean by transaction? What are the things which you should keep in mind while you have some use case of transaction related? So we will be deep diving into all those details. तो यार शुरू करते हैं. If you are not subscriber of the YouTube channel yet, consider subscribing. हम बनाते रहते हैं on the videos on system design concept, so you will keep on learning a lot of things, so consider subscribing. Let's move on. So if we talk about the basic gist about what transaction is. Transaction का मतलब क्या है? What do we mean by transaction? So if we say that I am transacting something, ठीक है, कि मेरे को पैसे भेजने हैं. So that's the basic idea we get when we say transaction, but we will be talking more around context of our DB transactions. When we say transactions, we will more discussing around database transactions. जो database में transactions हो रहे हैं, जो database में operations हो रहे हैं, we will be discussing more around that. So if we say what is transaction, so transaction is basically it could be a combination of multiple reads and write into a single logical unit. ठीक है. So let's say this is your logical unit. You are performing 2-3 operations. So operation 1, then operation 2, operation 3. So all those operations should be performed continuously or performed together. ठीक है. जैसे मैं फ्लाइट बुक कर रहा हूँ, आई एम बुकिंग अ फ्लाइट. सो फर्स्ट आई विल सी व्हाट आर द फ्लाइट्स अवेलेबल, देन आई विल सेलेक्ट वन फ्लाइट, देन आई विल select the seats, and then I will make the payment. So all those things can be combined in a single logical unit, and then they can be said that it is single transaction for a particular customer. ठीक है. So this is what we mean by a transaction. When we define a transaction, it will be executed as a single operation. It will be executed as a single operation. Now there could be possibility that there are multiple entities inside it. Let's say in case of booking a flight, वहाँ पे क्या हो रहा था? We have four steps combined into a single logical entity, so they will be executed in the single operation. तो अगर कुछ भी fail होता है, then it will be part of the transaction. समझे बात? ठीक है. So either all succeeds or either fail. When we define logical entity, if let's say this particular operation failed, this particular step failed in the transaction, so this complete transaction will be failure. For this transaction to be successful, we have to ensure that 1, 2 and 3 all should succeed. So समझे बात? This is what we mean by transaction. Now let's move to the acid properties. Acid का नाम आपने काफ़ी सुना होगा, कॉलेज में भी पढ़ा होगा. So what we mean by acid properties? Acid means atomicity, consistency, isolation and durability. What we mean by all these terms, let's deep dive into that. So acid basically is the safety guarantees provided by the transaction. ठीक है कि when I say that this is the transaction I am committing, so what are the basic properties, what are the guarantees which will be provided by this transaction? So let's discuss those. So first one is the atomicity. When we say atomicity, we mean that it will be atomic operation. Atomic मतलब 1 और 0. ठीक है. So you can't break into smaller parts. ठीक है. This, let's say this particular transaction, this will be your complete atomic operation. You can't break this into multiple parts. ऐसे नहीं कर सकते कि मैंने इसको break कर दिया, this is 1, this is 2. You can't do that. If you define this transaction, all these three entities will be in a single transaction. So it will be atomic operation only if this complete entity is defined as a transaction. Now if it will be only successful if all part of transaction are complete. For any fault it will fail. Okay, that we already discussed, that if any of the part from this three operations failing, then it will be leading to transaction failure. वहाँ पे ऐसा नहीं होगा कि partial failure हो गया, आधा failure हो गया, 30% failure हो गया, 70% failure हो गया. That's not the case. समझ रहे हो ना बात? That's not the case. If we say this is a transaction, all the steps in this transaction have to succeed. बात खत्म. समझे बात? Now let's move to second property, which is consistency. When we say consistency, what we mean by consistency is correctness of database. Correctness of database का मतलब, let's take one example. Transaction amount between two accounts should be balanced before and after the transaction. ठीक है. So let's say we have two users, user A and user B, and the total balance before starting the transaction is 500 and 200. User A has account balance of 500, user B थोड़ा कम अमीर है तो उसके पास सिर्फ है 200 रुपये. ठीक है. Now user A is transferring 200 to user B. User A is transferring 200 to user B. So in this case, what will happen? You have to deduct basically 200 from this and then add 200 here. This is what we mean by transaction. When we say transaction, it is here part of two steps. ठीक है. Debit from one account and credit in another account. This is what we mean by transaction here. So the amount should be same. When we say the total amount, पूरा हिसाब, total net zero होना चाहिए. So the transaction, before committing the transaction, the total value was 700. After the transaction, once the amount is being transferred, now user A has account balance of 300 and user B has account balance of 400. So total amount will be 700. If you see that net worth, net worth कितना है database का, it will be zero. So it should be zero. This is what we mean by consistency. This is what we mean when we say we have to maintain correctness of database. Let's move to the third property. Consistency में एक और point है. Consistency is like application property. So when we say acid properties, in acid properties, atomicity, isolation and durability, these are the database properties, and consistency will be more of a application property. Application has to ensure that the database is consistent by using these properties of database: atomicity, isolation and durability. बात समझ रहे हो? Now let's move to the third property, which is isolation. When we say isolation, what we mean by isolation is concurrent transactions occur independently in DB without compromising consistency. So when we say occur independently, there can be multiple transactions going on in database. ठीक है, ऐसा तो होगा नहीं कि मैं एक database एक operation एक time पे करूँगा या फिर I am performing only single transaction at a time. That is not possible. मतलब possible है, but that's not a viable scenario. समझ रहे हो ना बात? Like our database could be serving lot of traffic. Our database could be serving lot of traffic and we don't want other threads to wait for that or the transactions to complete. काफी queue बड़ी हो जाएगी. All the threads will keep on waiting for that transaction to complete. तो ऐसा हम नहीं चाहते definitely. ठीक है, we want कि कम से कम latency में, we want that in the minimum latency all those operations succeed, all those transactions succeed. So what we are trying to do here, that each transactions pretend that only transaction is being performed. ठीक है, so they are being performed concurrently, they are executed in parallel, but we will get a picture कि they are executing in serial. ठीक है, we will get a picture that they are executing in serial, they are executing in isolation. ठीक है, कि ये transaction A हो रहा है, ये transaction B हो रहा है. Now A transaction will not be aware of कि what's happening in B. They will execute in complete isolation in the thinking that they are the only transactions being performed in the database. ठीक है, we have to ensure that, and the result will be same if these transactions are carried out sequentially. ठीक है, like when we make these concurrent transactions, the result should be same if they are executed seriously. Let's say I am executing A and B together, but if I perform A and then B, the result should be same. This is what we mean by isolation. Now let's move to the fourth property, which is durability. Durability basically is related to storage की. एक बार data store कर दिया आपने, once the data is stored in the database, it should not be lost. ठीक है, so once you have stored the data in your database, वो कहीं जाना नहीं चाहिए. It should be present till the time you want it there. Like I'm explicitly deleting, then it will be not be there definitely. If I'm explicitly deleting any entry from the database, then it will be removed. But if an entry is committed to the database, then it should be present till the time it is not deleted. ठीक है, there should not be a scenario कि database उड़ गया. There should not be a scenario कि database is down, I don't have the data which I have committed earlier. I should have all the data which I have committed. This is what we mean by durability. When we say 100% durability, what it means is that the data once stored will be there always. Okay, so once transaction is committed, will be the data will be intact even in case of system failures. कोई भी सिनेरियो हो जाए, सिस्टम में गो डाउन, सिस्टम उड़ गया, रीजन चला गया AWS का, वट एवर द सिनेरियो इज, वी वांट कि डेटा वन स्टोर्ड इज ऑलवेज प्रेजेंट देयर. एग्जांपल, लेट्स से इन केस ऑफ B tree we discuss in our databases chapter that in case of B trees, let's say the in memory database weren't corrupt, so we maintain a WL write ahead log in the disk so that you can recover from that. So like in scenarios that your database went down, or like you have issues of with the durability, you should have proper mechanism in place so that you can recover that lost data. समझे बात? So you should have those mechanism in place so that you can do that. That will make our database durable. समझे बात? Now let's discuss around replication and durability. Now if we say that our database is durable, the one possible solution would be that you replicate the database to multiple places. ठीक है, मैं बोल रहा हूँ कि मेरा data मेरा database durable है. So one way could be that you replicate that data to multiple places. This is your database, ठीक है. So to make it durable, what you did, you replicated this data to multiple places. Let's say, ठीक है, this is in my US East 1 region. Now you also store this data into multiple places. Let's say US West 2 and one is Mumbai. मुंबई का रीजन कौन सा है? AP साउथ ईस्ट 1 आई थिंक. ठीक है. सो when we say we are trying to make database durable, ठीक है, we will make like all the configurations in place and we will have all mechanisms in place so that our database is durable. But it's more of a theoretical term. ठीक है, if you think about it, let's say I did replication, I did all those things, but still I lost the data. What if my replicas went down at the same time? There are very less scenarios that it will happen, but what if, like let's say I am maintaining my data in all the 7 regions of AWS. What if all the 7 regions went down altogether? ठीक है, ऐसा होगा, बहुत कम chances है. Like you can assume that it will not happen if you are designing a system or you are creating a system. Like Netflix I think operates in only 3 regions. ठीक है. So if you are doing that in 7 regions and you have replication in place for that same data in 7 regions, there are very less chances, very less chances that your data will go into corrupt state, or like you don't have data that you can recover from, you can recover your database from. ठीक है, there are very less chances of doing that. But if we think about it, that it's more of a theoretical concern. What if it happens? ठीक है. So वो बात है. ठीक है. Let's move to another thing. So single object writes. ठीक है. So let's say single object मतलब single object write कर रहे हैं हम. ठीक है, single object एक डब्बा. You are writing a 20 KB JSON to DB. Let's say we are using MongoDB and you have a 20 KB JSON. JSON कुछ यूज करता है ना MongoDB. But let's say let's say you are writing a JSON document to a DB. What if network issue after 10 KB is written? ठीक है. So do we have proper mechanisms in place to handle that? This could happen, right? That your 10 KB data is already stored there, but after that network issue occurred and you are not able to store that. Will you commit that data? Will you commit that? You should throw some kind of error so that it can be retried later. ठीक है. Let's say storage general. Another point would be storage engines in general provide atomicity and isolation at a single object level. Now when we say atomicity, uh, we mean that single operation will be the operation will be considered as atomic. ठीक है, 0 या फिर 1. ठीक है. Let example is log for crash. So in case of B-tree example, in case of B-tree we discussed that like we will maintain a WL write ahead log in case of failures. ठीक है. So like if any failures occur, then we will able to recover all this data from WAL. ठीक है. When we say isolation, we can basically add a lock on that object. ठीक है, कि अभी ये काम चल रहा है, like this particular write is going on, then I will not allow other writes to go on. ठीक है, so that the issue do not occur. What about multi-object transactions? So it could be possibility that let's take example of RDBMS. ठीक है, relational model के अंदर row in one table has foreign key inference in row in another table. ठीक है. Let's say I have these two tables. This is my PK and this is my FK. This FK is corresponding to PK of this table T2. ठीक है, this is T1. So there could be a possibility that write in this impacts right in this table as well. ठीक है. You also have to maintain entity in here, or probably you are deleting this entry from here, so it should be also be removed from here as well, because that are inference point. ठीक है. So these kind of scenarios will occur. Let's say you are updating multiple fields in the document. ठीक है, there is a document stored in your non-relational database, so you want to update some multiple fields in it. In case of secondary indexes, let's say this is your primary table, and you also have created indexes on top of it. Let's say you created 2 indexes, so any update which goes on here, and if that column like we have created second index on the top of that column, okay, so you will also update that index as well. So these are kind of scenarios when we say will be multi object transactions. ठीक है, कि एक ऑब्जेक्ट पे ट्रांजेक्शन हो रहा है, it will also impact other objects. ठीक है, that has to be updated so that our database is in sync. Let's say in case of indexes, ठीक है, if I'm making a making an entry in the main table, you have to also update that entry in the second index if that column is in concern. Now what about like let's say the transaction is aborted, ठीक है, let's say in case of this your multi objection transaction, one of this operation succeeded, ठीक है, but this operation particularly failed, ठीक है, so what you can do, you have to retry it so that it is not impacted, or like the user storage, like whatever a user is trying to store or whatever user is trying to write is not impacted or not क्या बोलते हैं, मतलब रिमूव हो गया, या फिर लाइक आई गॉट द रिस्पॉन्स दैट योर data is successfully written, but in actually there's some issue occurred in the network issue between main table and the indexes, and data was not moved to the indexes. So you should have some kind of retry mechanism in place, so that you are saying that my data will be written, तो my data will be written, ठीक है, मैं बोल रहा हूँ कि डेटा राइट हो जाएगा तो राइट हो जाएगा, ठीक है, मैं मान के चल रहा हूँ कि डेटा राइट हो जाएगा. नाउ what are the possible scenarios? So operation is completed on server but client didn't get response due to network error, ठीक है, operation was completed on the server, ठीक है, so let's say this is my database, this is my database, a user wrote the right query, ठीक है, the operation completed on the server, but it was not able to send the response back, ठीक है, ड्यू टू सम नेटवर्क इशू, या यूज़र वाज यूज़र के एंड पे कुछ हो गया, ठीक है, सो इन दैट कैन बी वन पॉसिबल सिनेरियो. अदर एग्जांपल कुड बी द एरर कुड बी ड्यू टू ओवरलोड, ठीक है, देयर इज सम ओवरलोड ऑन द डेटाबेस, ठीक है, सो द query might fail, ठीक है, your query is perfectly fine but there is some overload on the database, so your query will fail. So in this case retry might not help, ठीक है, because you will be only overloading your database again, ठीक है, your database is already overloaded and you are retrying again and again for those same queries, so you are creating kind of a cascading failure, ठीक है, कि मल्टीपल नोड्स मेरे डेटाबेस के थे, मैं ओवरलोड पहले से चल रहा है, आई एम हिटिंग मोर लाइक मोर अगेन एंड अगेन, लेट्स से फॉर माय सिंगल राइट क्वेरी आई हैव कॉन्फ़िगर्ड 3 retries, I have configured 3 retries, so you have to handle you have to handle somehow that. One possible way is using exponential back off and jitter, like you will not continuously hit it, you will configure some kind of timeout in between, ठीक है, let's say this is my first request, ठीक है, it failed and I got a retriable error, now I will wait for 200 millisecond, then I will try again, ठीक है, let's say it again failed, now I will add some exponential back off, let's say the factor of 1 or 1.2, ठीक है, so next time I'll add a wait time of 300 millisecond, or let's say 400 millisecond, ठीक है, so these are the configurations we have to keep in mind when we are trying to retry to the query, we retrying to any of these, like this will be applicable to any of the calls, ठीक है, ये database के specific हम बात करें, this can be related to your server itself, ठीक है, you are probably interacting within 2 microservices, so those microservices, when you are hitting from one microservice to another microservice, you should not continuously retry, you should add some kind of exponential backoff in between, so that your microservice 2 is not impacted and you are not hampering that service, like उसका मतलब 10 का TPS वो serve कर सकता है and you are hitting it with 20, so there can be some issues unless there is some throttling implemented at that level. समझ गए बात. एंड फाइनल पॉइंट इज वी शुड ओनली रिट्राई फॉर द टेम्पररी एरर्स, नॉट परमानेंट, ठीक है, सो इफ यू आर श्योर दैट even if you retry with the query, you are anyway going to fail, so you should able to bifurcate these errors into temporary errors and permanent errors, basically retriable error exceptions and non retriable exceptions. If you are getting retriable exceptions, then only you have to retry. If you are getting non retriable exception, then there is no point of retrying. समझ रहे हो ना बात, अगर आप retry कर भी रहे हो तो anyway it is going to fail, समझिए बात, एनी वे इट इज़ गोइंग टू फेल, सो वी शुड नॉट डू इट. क्यों करना है, मतलब पता ही है कि फेल होना है तो क्यों करना है, मज़ा थोड़ी ना आ रहा है, नहीं करना. तो वी हैव टू एंश्योर दैट वी आर ओनली रिट्राइंग फॉर दिस टेम्पररी एरर्स, नॉट फॉर परमानेंट एरर्स, समझे बात. Now weak isolation levels, when we discussed about our acid properties, right, there can be that it could be a possibility that we can support, like our use case is feasible to have weak isolation level, we don't require a strong isolation level, ठीक है, so we will discuss both weak isolation and weak isolation level and strong isolation level. So read data and B modifies data. It's like these are the some of the scenarios. So let's say A reads data and B modifies data at the same time. This is a concurrent operation going on. A and B try to write data at the same record concurrently. Okay, this is the database record, and there are two users, so the issue will only occur if things are happening concurrently, so we have to handle that somehow. Isolation की जो हम बात कर रहे थे, we wanted to make sure that even if these transactions are performed parallelly, we have to make look it like that it is being done serially, sequentially. So can you do that? How can you do that? अगर आप कर सकते हो तो कैसे आप कर सकते हो? We will discuss those ways at the end of this chapter. So when we say about transaction isolation, system works in a manner as everything is working in sequence. This we already discussed, right? And this is called serializable isolation. We will discuss this part at the end of this chapter. As strong isolation support has performance cost. Okay, when we say strong isolation, it can have some performance cost. Okay, you have to you have to ensure that the transactions are kind of sequential. So you have to make sure that when one transaction is performed on the same record, another transaction is not allowed. Okay, so that particular thread might wait for that particular time. Okay, so there might be some performance cost associated. So some database tend to use weak isolation level. अगर अपना यूज केस वो सपोर्ट कर सकता है, इफ आवर यूज केस इज फिजिबल टू सपोर्ट दैट एंड आर वी आर नॉट इम्पैक्टेड बाय दैट, देन वी विल मूव टू वीकर आइसोलेशन लेवल सो दैट वी कैन इंप्रूव आवर परफॉर्मेंस. ठीक है, समझ रहे हो ना बात? सो व्हाट आर द पॉसिबल, वन इज रीड कमिटेड. सो ऑन रीड यू विल सी डेटा दैट इज कमिटेड. ठीक है, ऑन राइट यू विल ओनली ओवरराइट इफ डेटा दैट द डेटा दैट इज कमिटेड. ठीक है, कंफ्यूजिंग हो गया क्या? जैसे लेट्स से दिस इज योर डेटाबेस. ठीक है, so you will only read the data which is already committed. You will not read any data that is not committed, or let's say for that particular object the data is there but it is not committed yet, so you will not read the data. You will only read the data which is committed, and same goes for write. You will only overwrite the data. You will, let's say this was your existing record here, you will only override it if it's committed. If it's not committed, when we say commit, either it's like it's stored or the transaction is aborted. There should not be an ongoing transaction on that particular record. ठीक है, या तो ट्रांजेक्शन पूरा का पूरा कमिट हो गया, इट वाज सक्सेसफुल, और इट इज अबॉर्टेड. देयर शुड नॉट बी अ सिनेरियो कि इट इज गोइंग इन बिटवीन, कि बीच में कुछ प्रोसेस चल रहा है एंड आई एम ट्राइंग टू मॉडिफाई दैट. आई विल नॉट ओवरराइट दैट इफ इट नॉट कमिटेड और अबॉर्टेड. So we are ensuring that there are no dirty reads and there are no dirty writes. Commit, if we are ensuring that the entry is already committed, and if we are trying to read it, we are ensuring that there are no dirty reads. If we are ensuring that there are the write is already committed and we are trying to overwrite it, then we are ensuring that there are no dirty writes. How can you do it? How can you ensure that there are no dirty writes? We can use logs. ठीक है, let's say your transaction A was going on. ठीक है, so if the transaction A is going on, I will acquire a log that no other transaction will be allowed to write it unless this log is released. ठीक है, let's say this is my write block. I will only be allowed to enter if I have a log. ठीक है, if I don't have log, then I will not be allowed to write. So this is how you can use it. In case of read as well, what you can do, you can use logs. Can lead to more wait time. ठीक है, this can be a possibility. So what you can do, there is another solution in case of reads. You can hold both old and new values for which update is going on, and you can return old value till new one is committed. ठीक है, एक database की entry है, let's say this is your database. This is your database. This is your database, and let's say my k equal to 3 and value is 5. So for this k equal to 3, some update is going on. ठीक है, so I'm keeping old value as well as new value, and the new value is not committed yet. ठीक है, so I am keeping this value 5 in my database so that I can return this value. And when this new value is committed, let's say 7 is committed, then if the read query comes, then I will return 7. ठीक है, so you're basically keeping a copy of old data and new data, and you will return the old data unless the new data is committed. Now there can be one disadvantage associated to it. Read committed can cause anomaly on read skew, जिसको हम बोलते हैं. ठीक है, let's take an example which will explain you कि हम क्या कहना चाहते हैं. So let's say you have two accounts, account A and account B. मनदीप के पास बहुत पैसा है, तो उसने क्या दो अकाउंट बना रखे हैं दो बैंक में. ठीक है, एक अकाउंट में 500 रुपये, बहुत ही ज़्यादा डॉलर में, डॉलर वाला मनदीप है. ठीक है, तो बहुत पैसा है, समझ रहे हो बात? तो account A contains $500 and account B contains $500. What I'm trying to do, I'm trying to transfer $100 from account A to account B. Both accounts are owned by me, so I'm trying to transfer $100 from account A to B. If I talk about total amount, total account Mandeep has, it's $100. $1000, गणित नहीं आती यार. 500 plus 500, total amount is $1000. So for the time being, if I read from this account for a time being, if I read from this account, the value is already deducted from here, so I will get that the value is 400. And it can be possibility कि if I'm looking at that same time, it might be a possibility कि अभी ये operation चल रहा है and I still see that the value is 500. The new value is not committed yet. The new value should have been 600 because I have transferred $100, but it is not committed yet. So I'm still seeing the old value. ठीक है, यहाँ पे हमने बोला था कि ओल्ड वैल्यू रिटर्न कर दो, बट इट कैन लीड टू रीड स्क्यू, दिस इज रीड स्क्यू कि आई एम स्टिल सीइंग द ओल्ड वैल्यू. ठीक है, सो इफ आई सी द टोटल अमाउंट इन माय ट्रांजैक्शंस, if I see the total amount in my transactions, it is 900. ठीक है, let's say मतलब it can be possible, there is a possibility that it will be it will appear only for a short time. ठीक है, once you refresh it, then you will see the new value. समझ गए बात. And this could be a like in case of single transactions it will not be a problem, but if you are running a big queries, let's say analytics use case, then I don't want these kind of use cases. ठीक है, this can impact my all the query analysis what I am trying to do. So in case of backups or in case of analytics use cases, you want to avoid these kind of scenarios. So what you can do to do it, first solution is snapshot isolation. Each transactions reads from consistent snapshot of database. So you will maintain a consistent snapshot of database for each of the like the database you are maintaining, and all those use cases can be served from here. All the analytics use cases or all the like the backups or anything you are maintaining, so these kind of scenarios, so that you can avoid this read skew problem. You can avoid this read queue read skew problem. You can maintain a consistent snapshot of a database, and it is extremely benefits long running read queries, backups, analytics जो हमने discuss किया. How you can implement it, so you will have a write logs to prevent dirty writes, and there are no logs required for read specifically. What you will do, you can maintain multiple versions of objects, unlike two in read committed. In case of read committed, you are only maintaining two values. In case of snapshot isolations, let's say in case of multi version MVCC, you can maintain multiple versions. ठीक है, जैसे ये मेरा database था, I created snapshot h1 at time t1, then I have snapshot h2 at time t2, then I have snapshot s3 at time t3. ठीक है, similarly you can keep multiple copies or like multiple versions of those objects, which we refer as multi-version concurrency control, MVCC. What about indexes? Let's say we also maintain indexes in our database. What about them? Secondary indexes, let's say secondary indexes, I have created a DynamoDB table, and there is one particular column जो काफ़ी ज़्यादा hit होता है. तो what I did, I created a secondary index for that. So one possibility that the index point to all the versions, index will point all to the versions, all the versions which you are maintaining for this for your database, and the index query you are doing, okay, it can filter out object versions not visible to concurrent transaction. Okay, so this could be one possible way. Another way which can be used, I think it is used by some of the database, that in case of B trees, what we earlier discussed was that in case of databases, the internal data structures which are used by databases, multiple RDBMS, they use basically B trees. ठीक है, तो in case of B trees, we discussed in that chapter that the same page will be modified. ठीक है, कि ये एक पेज है, इसकी वैल्यू पहले 4 थी, I got a new value, then I will update it to 6. ठीक है, so instead of overriding the value, what you are trying to do, you will create a new copy for a modified page. Let's say you will create a new page, instead of modifying this existing, let's keep it as it is, so that you can use it as a snapshot and create a new page at place of this. And the right transaction creates new B tree root, old root is consistent snapshot. समझ गए बात? So this can be one possible solution. Now let's move to one problem that can be associated with the techniques which we discussed right now. This is called lost update problem. Okay. So let's say this is your database. You read some value from this DB, then you modified the value, and then you wrote back the value. What if these operations are occurred concurrently? Let's say there are two users, user A and user B, and they both are doing the same set of operations on the same object. Now the two transactions are going on concurrently. There could be a possibility that one modification is lost. ठीक है, कि वैल्यू पहले 5 थी, value was 5 earlier, then I modified the value लेट्स से आई एम मेंटेनिंग ए काउंटर कि मेरे यूट्यूब पे कितने व्यूज़ आ गए, ठीक है, यूट्यूब वीडियो पे कितने व्यूज़ आ गए. सो द अर्लियर काउंट वाज 5. आई रेड द वैल्यू, ठीक है, एक नया यूज़र आया उसने व्यू किया. आई रेड द वैल्यू, देन आई मेड इट टू 6, ठीक है. Again, this write came, like the second user, it also got value 5, it updated as 6. So the value actually should have been 7, because there are two write operations, there are two write operations on the counter object we are maintaining, but actually only one write happened. This is lost update problem, कि जो update होनी चाहिए थी वो lost हो गई, गायब हो गई वो गायब हो गई वो ऑब्जेक्ट की वैल्यू. सो देर आर सम सॉल्यूशंस, ठीक है, जैसे हम हमेशा बोलते हैं, इफ देर आर प्रॉब्लम्स देन देर विल बी सॉल्यूशंस. समझे बात. सो फर्स्ट वन इज एटॉमिक राइट ऑपरेशंस, एटॉमिक अपडेट ऑपरेशंस बाय एक्वायरिंग लॉग, ठीक है. सो इफ एनी ऑपरेशन इज ऑलरेडी गोइंग ऑन, ठीक है, कि दिस पर्टिकुलर ऑपरेशन वाज गोइंग ऑन, लेट्स से आई एम परफॉर्म, I want to write some, I want to update some object, ठीक है. So I will get a log, I will acquire a log, and then I will write the value. So if any operations occur concurrently, there will be not a scenario that a log is assigned to all the users, both the users. It will not be a possible scenario, ठीक है. A single user can, only a single user can acquire a log. Concurrently भी आ रहे हैं तो then only then also a single user will acquire the log. So this can be one possibility. Another one is explicit locking, that handle locking by the application, ठीक है, कि हम डेटाबेस पे रिलाई नहीं करते कि वो लॉकिंग कैसे करेगा. वी विल हैंडल इट इन आर एप्लीकेशन, ठीक है, कि इफ एक यूजर अपडेट कर रहा है वहाँ पे, आई विल नॉट सेंड अ सेकंड क्वेरी देयर. So there could be possibility that it is not provided by the DB, that the locking mechanism is not available in the database, or you don't want to rely in that, or you have such a use case that database update or database locking mechanism will not be able to handle your use case. Atomic operations are not sufficient, so not possible to handle by DB query. Or for let's take example of multiplayer game, ठीक है, कि this particular player has to move from position A to position B. What if two users are trying to move this player A from place A to place B, ठीक है. So this you will have to explicitly handle in your application instead of relying on the database. Another way is detecting the lost update, ठीक है, कि मैं पहले ध्यान में नहीं रख रहा. If the lost update occurred, then I will see if there is a problem occurred and I have to retry something, ठीक है. So let it allow to execute in parallel, and if we see that there is some issue, if we are able to detect that there is some lost update problem, so we will fail the transaction, and then it can be retried later by application. So this can be one way. Compare and set. On update check, the current value is same on what it was read earlier. So let's say in this example only, right, where we say we are updating value 5 from 6, ठीक है. So when this value was being updated by second user, ठीक है, it should have seen value 5 because the 5 was read earlier, but it will the user B will see value as 6, ठीक है. So the user B can detect that there is some other write operation happened. So this could be another way to avoid this problem. Moving to another thing, we discussed about read skew. Let's discuss around write skew, ठीक है. राइट स्क्यू भी हो सकता है, रीड स्क्यू हो सकता है. तो सो लेट्स टेक एन एग्जांपल ऑफ बुकिंग ए मीटिंग रूम, ठीक है. लेट्स से अपना आउटलुक एप्लीकेशन है, कैलेंडर एप्लीकेशन है. आई वांट टू बुक ए पर्टिकुलर मीटिंग रूम फॉर माय टीम सो दैट वी कैन डिस्कस एनीथिंग, ठीक है. तो वी हैव ए सिस्टम डिजाइन डिस्कशन planned and we are trying to book a room. what if what if what if what if two users are trying to book the same room at the same time, ठीक है, एक टाइम पे, exact same time T1, exact same room R1. Two users are trying to book, user A and user B. Two users are trying to do this same operation at the same time and for the same object, same room को book करने की कोशिश हो रही है. So we have to ensure that same meeting room is not booked twice, and we have to ensure, like if the first you will check the availability कि you मतलब room available है, and then you have to ensure that if room is available then you have to assign it, ठीक है. So this could be a possibility in case of snapshot isolation, right. This could be a one issue with the snapshot isolation, that you check that the room is available and you went ahead and booked the room for both the users, but this should not have been happened. दिस शुड नॉट हैव हैपेंड कि दोनों यूजर्स ने रूम बुक कर लिया, कि दोनों को अवेलेबल दिखा, दोनों ने बुक कर लिया. दिस शुड नॉट हैव हैपेंड. दिस इज द इशू विद द स्नैपशॉट आइसोलेशन, कि यू आर मेंटेनिंग सम कॉपी, यू आर मेंटेनिंग सम स्नैपशॉट, and you are using that to refer the value कि the value is updated on, like the room is available or not. So you should not do that for these kind of scenarios. ठीक है. So you have to, like, if you take a gist, right, it will completely dependent on use case to use case. For one particular solution, one particular use case, the snapshot isolation work fine, like we don't have any problems, it is 100% fine to use snapshot isolation. For but another use case, there is a use problem. ठीक है. In case of this booking a room problem, ठीक है, I am maintaining a calendar application where I can book rooms. I can block the particular time, and that particular time आई एम बुकिंग द रूम. ठीक है. मेरे को 1 बजे से 2 बजे तक रूम बुक करना है. तो इफ द रूम इज अवेलेबल देन ओनली आई बी अवेलेबल टू बुक द रूम. ठीक है. इफ देर इज नॉट एनी अवेलेबिलिटी इन केस ऑफ स्नैपशॉट आइसोलेशन, आई विल सी दैट देर इज अवेलेबिलिटी ऑफ रूम. शो आई विल बी एबल टू डू दैट. पर वो ऐसा होना नहीं चाहिए था. हाउ कैन यू सॉल्व दैट? To solve this, you should do serializable isolation. We discussed in some point. We will discuss more around, but we also discussed some time back that we will try to execute the operations sequentially. At least they should appear that they have occurred sequentially. So this is what we mean by serializable isolation. Another thing is that you are locking multiple rows that are accessed for transaction. This is one other thing we should know, what we mean by phantom. Write in one transaction, change result of search query in another transaction. ठीक है. तो multiple transactions के बीच में issue नहीं आना चाहिए. Moving to serializability. ठीक है. तो हमने थोड़ा सा डिस्कस किया था इसके बारे में कि serializability जब हम बोलते हैं, what we mean by serializability is कि even if the transactions are happening in parallel, they should appear that they should appear like they are being executed sequentially, serially वो हो रहे हैं. So this is what we mean by serializable isolation. The transaction may execute in parallel, but they have same effect as executed sequentially. There is no concurrency. How can you do it? कैसे कर सकते हैं? First one is actual serial execution. कि actually हमने दिखाना नहीं है. Actually they are executed in executed sequentially, one by one. ठीक है. So there is no issues. Concurrency related. ठीक है. There can be some performance related issues, but if we are sure that we have data present in memory, we don't have to make any calls to disk. There is data present in memory, and I have high enough RAM to support all those operations. CPU अच्छा है, RAM अच्छा है, तो वो जल्दी से हो जाएगा. My thread will not be in a block state. So you can think of this, that instead of handling all those concurrency, instead of all those conflict resolutions and all those things, what I will do is to handle this, I will actually make my system सिंगल थ्रेड. ठीक है. सिंगल थ्रेड पे मेरा सिस्टम चलेगा. एक राइट क्वेरी चल रहा है तो वो राइट क्वेरी चलेगा. वंस दैट राइट क्वेरी इज कंप्लीट, देन ओनली आई विल डू द अनदर क्वेरी. आई विल एग्जीक्यूट द अनदर क्वेरी. ठीक है. तो दिस इज वन पॉसिबल वे, एक्चुअल सीरियल एग्जीक्यूशन. अनदर वे इज एनकैप्सुलेट ट्रांजेक्शंस इन स्टोर्ड प्रोसीजर्स. ठीक है. सो what we mean here is, let's say you are booking a flight. The example earlier we discussed when we started this chapter. So in case of transactions, we discussed that this should be treated as a single transaction. You are looking for a flight, then you selected particular flight, you booked some seat, and you made the payment. Now instead of making this as single transactions, what if we make these transactions broke into 4 parts? ठीक है. अगर हम सिंगल थ्रेड मेंटेन कर रहे हैं, इफ यू आर मेंटेनिंग ए सिंगल थ्रेड, सो दैट so as you avoid कि multiple threads are not held, और multiple threads are not held back for the execution. ठीक है. कि हम क्यों में स्टोर किए जा रहे हैं कि भाई बड़ा वाला ट्रांजेक्शन चल रहा है, जब वो कंप्लीट हो जाएगा then we will proceed with another transaction. ठीक है. So to avoid those kind of scenarios, what we can do, we can break the transactions into smaller parts. ठीक है. There is a possibility that the processing time will decrease. कि एक पर्टिकुलर थ्रेड को हम होल्ड करके नहीं रख रहे. इफ देर आर सम अदर क्वेरीज अवेलेबल टू एग्जीक्यूट, दे विल बी एग्जीक्यूटेड. सो इट्स beneficial if you make this transaction short. ठीक है. To support serial execution, transaction should be short to avoid lag due to locks. Application should submit entire transaction code to DB ahead of time. ठीक है. So this is what we mean by stored procedures, कि आपने पहले ही DB को बता दिया ahead of time कि this is the piece of code you have to execute when this write query comes. So there is no IO wait time, there is no IO wait, and there is no concurrency overhead. Another way is two-phase locking. This is different from 2PC. फेज कमिट, टू फेज कमिट, ठीक है, दिस दैट वी विल डिस्कस इन कमिंग चैप्टर्स। तो अगर हम टू फेज लॉकिंग की बात करें, there will be the several transactions are allowed to write to an object unless no one is modifying it, ठीक है। You will understand it with this example. So let's say this is your database. In this database, A is reading and B can write. If A is reading, B is allowed to write. If A is writing, then B is allowed to read. ठीक है, there will not be a scenario कि A भी write कर रहा है, B भी write कर रहा है, समझे बात। So we should wait until A commits or aborts, ठीक है। If A operation is going on, गलत हो गया, मैंने जो बोला वो थोड़ा सा गलत हो गया, ठीक है, तो उसको स्किप कर देना। If A is reading, then B will wait so that A is only reading the committed value, ठीक है। B will not be allowed to write unless A has कमिटेड कि हाँ मैंने रीड कर लिया है या फिर मैंने अबॉर्ट, मतलब जो भी करना है, ट्रांजेक्शन कंप्लीट हो गया। सिमिलरली इफ बी विल वेट अंटिल ए कमिट्स और अबॉर्ट्स, इन दिस केस ए इज राइटिंग एंड बी इज रीडिंग, सो बी विल वेट अनलेस अंटिल ए कमिट्स और अबॉर्ट्स, ठीक है, कि राइट ऑपरेशन इज कमिटेड और अबॉर्टेड। नाउ देयर माइट बी सिचुएशन ऑफ डेडलॉक, देयर कुड बी अ पॉसिबिलिटी कि ए राइट किया जा रहा है, ओहो बैक होता है क्या, यस होता है। So there might be a possibility कि you acquired a lock for writing, A is writing and you acquired a lock, ठीक है, this is your lock, you acquired a lock and this is taking too much time, this thread is in block state, so you should like what we say, you should क्या मतलब, not getting a word, बेसिकली वो पकड़ में आना चाहिए, ठीक है। यू शुड बी एबल टू आइडेंटिफाई दोज, यू शुड बी एबल टू आइडेंटिफाई दोज सिनेरियोज दैट देर इज सम डेडलॉक सिचुएशन। सो इन दिस काइंड ऑफ सिनेरियोज व्हाट यू कैन डू, यू कैन बेसिकली अबॉर्ट दिस ऑपरेशन, देन इट कैन बी रिट्राइड, ठीक है। सो दिस इज ऑल अबाउट आवर ट्रांजेक्शंस चैप्टर, वी विल बी मीटिंग अगेन इन आवर नेक्स्ट चैप्टर। तब तक के लिए स्टे सेफ, टाटा बाय बाय, स्टे लर्निंग।